Hey guys, so David here, and I think today I'm going to be going over dominoes D1, so problems D1 and D2, on the recent Codeforces Round 7 through 4. This was a while ago. I think I solved A through C, so A and then B1 to C. I think I did it pretty slowly though, so I wasn't able to get a chance to fully dive into D1 and D2. I did read their problem statements, but I couldn't get a solution, so poop. But I think D1 and D2 has a really nice solution, and I kind of want to go over it. Except D2. D2, I hate D2. I'll explain why. But yeah, so basically, you're given three numbers. I'm going to use light blue today. N, M, and K. So N and M stand for the number of rows, which is N, and the number of columns, which is M. And so this is a 4x4 grid, so N by N, or 4x4. So yeah. So N and M stand for the graph, or not graph. Yeah, don't want to get that confused. N and M stand for the grid, and K, or actually I'll explain this. So your goal is to put dominoes in a way that it fills every single square. And there's two types of dominoes, right? The first type of domino is vertical, where it's a height of 2 and a width of 1, and a width of 2 and a height of 1. So that's horizontal. And so you'll notice that both of them only have the area of 2. So we automatically know that if n times m is odd, or it's impossible because it's not divisible by 2, which they already cover it. It's always even, I think, in the problem statement. Yeah, so, but that's just like from, yeah. And so you'll also notice, okay, I'll explain K too. So K is also the amount of horizontal, the exact amount. So if it says 3, you can only use 3 horizontal and the rest must be vertical. And so I guess I'll outline a few key observations. First one is that if it's not, the domino, if a domino is not horizontal, it's vertical. And yeah, that's kind of self-explanatory, but it will help explain later stuff. So the easiest case for n and m is whether it's even, or if both of them are even. So if n mod 2 is 0, so if they're both even, right, what we can do is we can just make squares. We'll just use horizontal. And so if we take 2 out of the k horizontal squares, we can make, or 2 out of the k dominoes, we can just make these squares and then fill up the rest with vertical. And as long as k is even, we can make one square because that consists of 2 dominoes, right? And if it's odd, so let's do 3, what ends up happening is that we have to try to make a square or fill out the area with both a vertical and a horizontal, which can't work no matter how much you try. Yeah. And so k has to be even, and if it is even, we can just fill up the rest with vertical, right? And since we know n and m, n times m divided by 2, so the amount of dominoes is n times m divided by 2, and since we know this is even, we know n times m is even, we know that, no, scratch that, do not, that is a bad observation. I just found a wrong thing about that. But the idea, yeah, so if n is even and m is even, that means if k is even, it's good, and if it's odd, it's impossible, because we have to combine both vertical and horizontal. I was trying to be smart and trying to think of a cool observation, but no, it's wrong. It's usually easier than it seems. Now, here's the more complicated ones, which is not too complicated. If n is odd, right, the number of columns is odd, what we can do is we can just fill up one column or one row, right, with some dominoes. And what ends up happening is we'll literally just get the same case, right, except we just filled up the top, which we know is even because n times n is even, and if this is odd, that means m is even. So we can just fill up the top, and then we'll get back to the base case, which is even. So the total is 5, 4. We just subtracted it to make it even, and now we're good. And now we'll do the same thing. K, if k is even, right, we'll just make some squares, square. And if it's odd, it's impossible. If it is, it's possible. Now m is a little bit tricky, but it's not too bad. So if m is even, all right, so we'll do the case 4, 5, right? What we'll do is we'll just take one column out. And in order to figure that out, we'll change k equals to n times n divided by 2. So that's the number of dominoes minus k. And we know that if a domino isn't horizontal, it's going to be vertical because there's only 2 choices. And so we'll take out that first column and then see if the remaining k, so k minus, it would be actually n divided by 2 because that's the amount that of dominoes needed to cover one row. And we can just make more squares after that. If k is mod 2, which just means it's odd. Poop. What do I say? Odd, it's not good. And if it's even, it's good. That does not look like a k, but whatever. And yeah, same principle here. We can't combine a horizontal with the vertical. And that's like the odd case. And we can just make more squares. So yeah, that's kind of the solution. I'll go over the code real quick. But so this is the easiest solution, right? If it's both even, we don't even, like, there's only 2 cases where if k is odd or k is even. Here, we just take out the first row, which is length m divided by 2, because m is the horizontal length, and if we take out, if we divide it by 2, that's the amount of tiles or dominoes. And then what's nice is it's literally just the same as this first base case, like I said earlier. And the only difference is here, because we have to check if k is able to take out that first row or fill up that first row. And here we just switch it to verticals. So this is the case where m is odd, so we have to take out that first column. And when we take out that first column, it becomes a both even case. And yeah, so n divided by 2 is the amount of dominoes it takes to fill up that first column. And same idea here. If k is less than 0, it's not possible because we can't fill up that first column. And if it's even, it's not possible because we can't combine a vertical domino with a horizontal domino. Yeah, it's pretty cool. But now that's D1. Now for D2, I don't like D2 because it's an implementation problem. And I don't think implementation problems are bad in a sense, it's just I'm bad at them, and I'm not good at them. And you'll notice I have done this like 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And I've got it wrong 8. So, and the last time, I think I literally just copied the editor. But I had an issue where, I have a solution, don't worry. But I had an issue where, I'll explain my solution, I guess. So we just do the same idea, like if it's even, we'll fill up the grid. If it's like if n or m is odd, we just first fill up the first line or column or row. But the issue was that if, like, let's say we want to fill up like a certain amount of squares with vertical dominoes, right? So I'll use A and B, right? So I'll go A, B, A, B, A, B. I'm kind of suck at this. Okay. And this was easy because all we have to do was just alternate when we're in a row, right? Skip to the +2, and made sure that we switch at the very, or yeah, we switch at the very end. Yeah. So every time we switch, or actually, yeah. So an easy case would be, since it's always even, we like, okay. Yeah, I guess the solution here, what I could probably do is that the first line, right? I'll just alternate. And then after that, when you go to your next line, you check above, and if it's A, you'll go B. If it's B, you'll go A. And you don't have to check above every time. We can just alternate again because we already know it's good. Gosh, okay. But when we just go to the next two columns, or two rows, we just check above. We can do that. That should be able to work. And I didn't do that because I'm too lazy to implement, and I hate implementation, but it's okay. Implementation is probably like the backbone of programming, so but yeah, that's kind of like my kind of solution. I don't know if it works, but give it a try. Yeah, so that was D1 and D2. Hope y'all like it, and that'll be it. See ya.